All right. Good morning, you guys.
Good morning.
All right, so what we're going to be doing today, as you know, is a continuation of what we've been doing. So, first day we did our graphic organizers, correct? We did our posters on cellular respiration and photosynthesis. Then the next day was what? What did we focus on primarily? What was the main process that we focused on? Photosynthesis. All right, we focused on photosynthesis. Just quickly, what are the inputs of photosynthesis? Look at your notes if you don't know. What are the inputs of photosynthesis? Carbon dioxide, light, energy, and water. Yes, yes, yes. Now, what are the outputs of photosynthesis? Yes. And now we're going to get into our lab, which is going to talk about what? We talked about photosynthesis. Now we're going to talk about what? Cellular respiration. Right? Which is what? Who does that? Plants or animals? Animals. We'll talk about that. There are some that do both. Who said both? I will give you extra credit for that, sir. That is a very true statement. All right, so again, just to go over our background, we have bromothymol blue, which is a chemical. I'll say this first in terms of what I'm about to say about it versus how chemicals are and how important they are for you to handle them carefully. So this is bromothymol blue. Anytime when I'm in the lab, when I look at it, you have something I told you called SDS, a safety data sheet, right? That lets you know what you're working with, what to do if it harms you, ingest it, get on your skin, get in your eyes, inhale it, right? I told you, if you have something that's lipid, oil-based, do you want to put water on it? What happened to it? Yes, you ever see the YouTube or the TikTok on the guy that puts the guy or girl that puts the frozen turkey in the big thing and it blows up? Why did it do that? What did he not do to the turkey? He didn't defrost it, right? So when you put a frozen turkey in there, it's water, right? Exactly. That's exactly the sound it makes. All right, so it's a chemical indicator, right? What is a chemical indicator? It lets us know what? What's an indicator? It's going to let us know what? Information. Right? So, in this bromothymol blue, it says 0.04% bromothymol blue. That means that 99.9% of this is water. Right? But look how it looks. Does it look like it's on what 0.04 means? That means if it was 1%, for every one part, I do 99 parts to get to 100 of water. Bless you. Right? This is 0.04%. But even though this is 0.04%, if you were to ingest this, you would get diarrhea. Right? In terms of this being our first lab where we're working with chemicals, I don't know if the look of the smile and the shaking your head is because it's cool or you're scared. Which one? I think it's cool too. I'm not mad. I agree. All right, so again, this is how you would begin the lab. First aid in eyes. Rinse carefully with water for several minutes. Where's our wash station? Okay. Remove contact lenses, but we have what? And if you are wearing glasses, do you have to take them off or can you wear them as well and put them on top? You just put them on top. You don't have to take off your glasses. If present needs to do, continue rinsing. If eye irritation persists, get medical and advice. After contact with skin, wash immediately with plenty of water. If swallowed, do not induce vomiting. Right? That's why it's important to read this, because if you swallow this, would you naturally think to try to throw it up? Yes. But this is saying do not induce vomiting.
Why?
So what are some reasons? Depending on what this chemical is, what don't you want it to go back up to do?
Burn your throat?
Your throat. I would even add another, because I don't know the answer, but using my scientific mind, we don't know how this reacts with an acid. Right? And is our stomach acid?
Yes.
All right, so quickly, is this blue thing, is it a base or an acid? It says it's yellow in acidic solution, blue in basic, green in neutral. What are we working with, a base or acid? Okay, we're working with the base. And when it introduced the carbon dioxide, it makes carbonic acid, which turns into a pH of 5.7, which we know is acidic, right? And then where's our carbon dioxide going to be coming from? Us, right? All right, so number one, how is breathing related to cellular respiration? Easy. Yes, Maya. Yes, we produce what plants need. And what is that stuff that they need? And there's two other. Carbon dioxide, water, and sun, light energy. Hypothesis, how will exercise affect the rate of cellular respiration? What will exercise do to the rate of cellular respiration? Not you, Amaya. Let's go to, yes, sir. It's going to speed it up. It's going to increase it. And how will bromothymol blue pH help you measure the rate of cellular respiration? If it goes from blue to yellow with the introduction of more carbon dioxide, what is it going to tell us about cellular respiration? In terms of what my gentleman over here says is going to increase the rate. What should we see in terms of that rate of going from blue to yellow? Should it go from blue to yellow the same before and after exercise? What should we see after exercise?
A different color.
Not a different color. What about the rate? Would it be faster or slower? We'll see. I hear some say faster, I hear some say slower. Hopefully that's in your hypothesis, right? Hopefully that's in your answer. But we are going to see. What are we going to do? Our lab experiment. What is our lab experiment? Bromothymol blue. Here's a beaker with bromothymol blue and water. Everybody's desk has a cup with a straw. What you're going to do is you're going to have one person, anybody, you guys are in groups of two, who are going to grab that cup. I'm going to put some bromothymol blue in it, and the other person is going to use a stopwatch. Right? After that, you're going to blow into the bromothymol blue. Now, I just said if you ingest it, it's going to do what? Give you what? So, what should I be careful not to do as I'm blowing in this? Yes, right? Which is something that you can do accidentally, correct? So be careful, don't. Right? I would also suggest step away when you inhale, right? Because we're dealing with a, okay. After that, you will record how long it took. And then after you record how long it took, we are going to go outside, and then you guys are going to run 4 laps up and down this hallway so we can bring up what? Our heart rate, which is going to increase cellular respiration. You're going to do the exact same thing. You're going to blow in it. The other person is going to do the stopwatch, and you're going to see your time. Is it slower? Is it faster? And you're going to record. Does everybody understand? All right, let's put on those goggles. Yes, you can. So just to reiterate, so we're all on the same page, you not start your stopwatch until the person starts to what? And then the person on the stopwatch immediately stops the stopwatch when it turns what? What color are we looking for? Right? This is a color. This is an indicator. It's telling us what. Thank you. Let me put on my goggles.
You guys Google a stopwatch, the one that's doing a timer. You're gonna Google the stopwatch and you're going to put the data on the data chart. You're the timekeeper and you're data collector.
to be scared of. So I'll say this. If you're scared, what's a way to make sure that you are not scared? Is to be what? Careful and what's the finesse? Safe. Yes. All labs have a protocol for a reason. You guys can begin. But again, begin, but make sure that your person with the stopwatch is ready for you to begin. Yes, you can, but when you start, you're ready, right? You gotta let her know when it starts. Say ready, set, go. As soon as it turns that color, you stop. But that means the person with the stopwatch has to be the observer. Did you stop? Yes. Yes. Are we seeing a color change? Okay. You guys good? Okay. So, are we recording this time? How do you know when it is? Write it somewhere. I want to see it in all your lab notebooks. Record the time. Right? It should look like this. The graph that you use should look like this. Time of activity, before exercise, after exercise. And then the time of color change. I need to blow a little harder. Stop it. Did? Okay, there you go. Yes, it did. After you guys have recorded and you have written it down in your lab notebook, come up here and pour your solution in this beaker. After you pour your solution in the beaker, I'm going to give you a fresh sample of bromothymol blue. And then what are we doing with this sample first? Before we do anything, we're going to put it on our desk and then we're going to go where? Run. Somebody said it doesn't have a smell. How do we smell things in the lab? We waft it. You use your hand. You do not put your nose to the sample. Yes, you can waft it first. All right, let's empty it out so you can get your new sample.
All right, let me make this clear, guys. You're going to go, don't go outside with your bromothymol blue. Leave it on the table. Mr. Caskey said you're going to run up and down the hallway. He's going to be out there to monitor you. When you come back in, you immediately start blowing. And your timekeeper immediately hits start.
Go.
Are we clear? All right, going outside.
Yes, everybody can do it.
Your timekeeper needs to stay. Don't wash your hands after. Yes. If you're timing,
Mr.
sit
McLean.
down. You're timing. Sit down. They're gonna run back in here, and you gotta hit start.
You're still going. Yeah. Yeah.
You have to be ready to hit start.
So all the time I'm running.
No. No.
So I go out there.
You don't know. He's gonna come back
That was 4? Four. I need to build up that cellular respiration. I need a lot of carbon dioxide in these samples. Hmm? I need a lot of carbon dioxide. Increase the rate of cellular respiration. All right, I like what I'm hearing.
All right.
Fine lady, back to
Like what I'm hearing. Remember, as soon as you sit down, your recorder lets you know when to start. You start as soon as you can. As soon as they sit down, give them the countdown.
Can't breathe.
Looks like some of you guys need to exercise more.
Write down your data point. Stop. Both of y'all did?